Thank you, everyone, for joining us today for our monthly Cubit webinar. And today we're discussing the first 15 minutes of using Coreform Cubit. We're just going to run through the very, very basics of using Coreform Cubit for the first time. Greg Vernon will be our host today. He'll walk you through. As you know, if you've joined us, Coreform Cubit is a meshing toolkit for challenging simulations. With a number of features that you can see on the screen. But of course, today we're just going to be focused on the very basics and get you started so that you can get to this point where you can make meshes like you see there on the right. All right, Greg, why don't you go ahead and get started?
So just to begin, I just wanted to go over the the interface for Coreform Cubit once you've loaded it up, and just some of the basics you'll see here, and you'll see in our documentation. So we have a layout where we have a graphics window in the middle where you can do all of your selection of items, see the updates to your model as you're meshing it or preparing it for meshing. You'll see entities that are in the graphics window will be represented in the model tree. So you'll see that there's lists for like volumes that you have, as well as if you're doing like sheet metal modeling, there will be sheet bodies, but you'll be able to access all the surfaces and stuff from within there, as well as you add different set assignments for assigning materials. You'll see those here as well. Um, Also, when you have selected different entities in the graphics window, there's a properties page that will then give you kind of an overview of some of the high level information. Some of these values in here can actually be edited in place. So if you want to add a size, you can use some of the tools we're going to talk about today, but you can also directly set them here. And you can do things then like compare the meshed area versus the actual. It's blocked by this, but there's an actual area that you could add then of the CAD that you can compute. So it's really great for some quick and handy verification. We also have a command line. Cubit, when it was initially developed, was all command line. There were no graphics. And then as the GUI was developed, and as buttons and shortcuts, graphic shortcuts were made, all of those buttons and commands or issue commands, and you can then see the history of them in this command line, as well as then enter them yourself. So many times advanced users will start to just use commands rather than use the GUI or using GUI tools. There's also on the right here, there's the power tools and command panel. You can see that there's sub-tabs on the bottom here for the power tools, which is where we're going to focus today. Power tools is typically where we recommend most new users begin. And then many people find as they're transitioning towards a command line interface that they'll use a command panel layout as maybe a quicker way for them to do things that were in the power tools. That they no longer really, you may not need your hand held as much. We also have a toolbar, which is reconfigurable by you, so you can drag and drop things around. This is where you can do things like choose what kind of entities you're selecting, whether it's CAD entities or mesh entities, as well as change like the view type of the geometry. So like transparent or solid. There's also then the menu bar, and we're going to talk about the menu bar in a little bit here. But before we move on, I do want to recommend that new users use the power tools. But there's a couple kind of key concepts of Cubit to understand. One is that Cubit is based on the Exodus mesh format, which has three main entity types. There are blocks, which is traditional defining an element connectivity, where you can then assign materials, different element formulations, or body loads onto. There are then side sets, where you can select kind of the sub-elements of an element, so the surfaces and edges of elements. And the key is that there is some connectivity information, which then allows you to assign boundary conditions or load conditions that might need to compute, say, a face normal, or you need to know the area of the element face so that you can apply a pressure distributed over that. And then there are node sets, which, as it suggests, just selects nodes, which you can then use to assign, say, a Dirichlet boundary condition, use as a reference point for multi-point constraint, so like spider joints and stuff like that. And so that's what you'll use with node sets. While you can pick the individual mesh entities themselves, you can also make sets out of the CAD surfaces, and then when they're meshed, they will then if I'd say assign a side set to the surface, it will then automatically grab the elements that are in, or the faces that are in that surface. And a second big concept to understand too is when you want to create contiguous meshes, that the operations in Cubit that decompose CAD objects into their smaller objects for meshing are called web cuts. And in Cubit, unlike some other tools, web cuts create disconnected regions that will not produce contiguous meshes across. So what we need to do is we need to merge duplicate co-located entities, so like two surfaces that are duplicates between two volumes. We'll need to merge those together so that instead of two surfaces that are independent, there's only a single surface that's shared. And oftentimes that means that we need to imprint operation or apply imprints to, say, two volumes to translate their topologies to each other so that then you have those duplicate entities that you can then merge. So just to show that in action, here's two entities. I've pulled them apart so you can see that there's clearly a different mesh on the cylinder than there is on the yellow. I've produced these after I've cut what had been one volume into these two volumes. You can see that there is no duplicate surface of the circle on this cube. So we imprint, and that translates this circular surface onto the planar surface of the cube. But if we do a mesh, we still don't have a contiguous mesh here because there are two separate entities that are unique. So we then do a merge operation, which you can see here now, there's only a single surface that's shared between the two entities. And then the mesh from there would then mesh the green cylinder and mesh the yellow cube for a contiguous mesh. So you'll oftentimes hear or see us talk about imprint and merge. And it's not always required to imprint, but oftentimes you do need to imprint and then merge to produce your contiguous mesh. And then the last thing that a lot of users will want to do is set some custom options. So in the menu bar, tools, options, it gives you a lot of different things here to set your graphics tolerance, so how smooth your CAD looks, whether or not you want to display the CAD vertices, changing geometry colors, and a whole bunch of other options as well that you may want to customize relatively early on in your experience. So with that, I want to now just transition over to a live demo of Coreform Cubit. So we're going to use the power tools. Again, in my standard setup, I typically have the command panel. So I'm going to switch over to power tools. If you don't have the power tools showing up, you may need to use the view menu bar and make sure that the power tools choice is selected. So you can see if I cycle that, I go from not having power tools to having power tools. Now, the item wizard, which is this wizard's hat, then kind of gives you from top to bottom a process to produce your mesh. So the first step we're going to do is import our geometry. So I've got three options here. I'm going to, in this case, import a CAD model. The native format for Cubit is the ASYS format. I'm going to import this simple.sat file. I have some options for how I want to import. And again, that has issued a command to the command line. That's probably a little bit beyond your first 15 minutes, but it's good to know that it's there. So now we see we've got our CAD geometry imported. I like to have black curves as opposed to the lighter colors. So again, that's where I'm going to set my options, where I'm going to choose that my vertex color should be black, and my curve color should be black. That is a personal preference of mine, and you may find that that's a preference that you like as well. So now that we've imported our CAD, we can just click on Done. Our next step is to set up the FEA model. This is kind of helpful to kind of get an idea for if you have an idea for how many elements you want to have. I could say I want about 1,000 elements that I want maybe hexahedral or tetrahedral. And by applying, it will apply a size that Cubit estimates will give me around 1,000 elements and an approximate element size. Now here I'm kind of previewing what the mesh might look like on the curves. At any time, there is this magic mesh button that I could just click, and if Cubit can build a mesh, it will just build the mesh. For now, though, I'm just going to delete the mesh, and we're going to work through the rest of the wizard. So after we've kind of set up our initial FEA model, kind of with some basic settings, we'll move on to preparing the geometry. Now, this is a simple model. It won't have any issues, but there's oftentimes some bad CAD or very small features that need to be cleaned up, or you'll need to build that meshable topology, like I was saying, and so we can run diagnostics, and it'll check to see if there are any issues. Now, it's not necessary for everything to be green because sometimes there are small features that are actually needed, but it does kind of help you. If you click on each of these, it'll help walk you through healing models if they need healing, removing small fillets and other small entities, and then cutting and everything. So in this case, we're ready to go on to our next step, which is to mesh the geometry. Again, here, we can just simply generate the mesh since everything was already meshable. In cases where it couldn't build a mesh, then this tool will then give a quick overview of what was meshed and what wasn't meshed. You can then do things like checking your mesh quality. So we can look at for this model here, we're getting a shape quality here, and it's telling us that there are no bad entities based on some properties we requested. You can define what those quality metrics are by going to the first step of that, and maybe you want to compare by scale Jacobian, and like what your min and max scale Jacobians might be, and you can use that then to check your quality. If you had bad quality, you could do some refinement. You could delete the mesh and recheck things. In our case, again, we're going to just move on to now where we can define our boundary conditions. Cubit here is letting us or helping guide us that if we want to apply node sets, to say in this case, we want a Dirichlet boundary condition on the back side. So we want to maybe have a fixed displacement. We can select by the surface again. So the key here is that, again, I'm selecting a surface, not necessarily the entities, and then those will just be carried. So I might call this fold bottom is, or maybe I'll just call this bottom surface for my node set name. Maybe I want to apply a pressure on the front surface. So if I go back to my power tools and define side set 1 is maybe load surface, and selecting the CAD entity. And then I want to assign blocks. And so now maybe I want this to be an aluminum. I guess the wrong way. One for here, block 1, it's aluminum, and I'm applying it to the volume. Now it's automatically, if we look at our model tree and look at our properties, it's automatically grabbed the elements that are in that block or in the volume that we assign the block to. It's done the same thing with the side set and with the node set. Now you'll notice that in this case, as I selected the define node set side set blocks, it pulled me over to their location in the command panel to help get you experience there. We can then define our materials and some other boundary conditions. I'll save that for a later presentation, as they're just mostly the same walkthrough. But once we're done with that, we're now ready to export our mesh, and we can choose to export to Genesis, which is the same as the Exodus mesh format that we talked about earlier, or to Abacus, Patran, Nastran, LS-DYNA, or other formats. So let's choose to export. We'll call this my first mesh. And as simple as that, we've now got our first mesh written to a file, and we can now run a simulation on that. So those are your first 15 minutes to Cubit. My recommendations are that once you've gotten yourself familiar with the command panel, with the power tools, and especially the item wizard, that you can start to look at the other power tools that are involved in it, and then slowly start to build yourself out to working within the command panel. And then once you feel comfortable with the command panel, what many advanced users will then do is they will use the command panel to give themselves kind of the outline of what their commands are. They will start then pushing those into journal files. So say they'll copy what they have in their history. Let's copy a whole bunch of this. They'll throw it into a journal file, and then they may even start to move those to Python. And we'll have a whole bunch of webinars to talk more about that in more detail later. But that's your first 15 minutes and a view ahead here next maybe 15 hours in Cubit. So with that, I'll open it up to Q&A. So I see a question here. Do merge rules require a side set to side set only logic? So no, if I understand that question correctly, it's kind of back to the PowerPoint slide that we had on this. The question is, I think, whether or not it can only merge surfaces. And it's not the case. If we were to have a, say maybe just two rectangles, let's just create a couple rectangles here of width 1. But even in this case, I mean, I'll move it again just a little bit so we can see the gap. The merge between these two surfaces would merge these two curves together and their subvertices. So it can happen on at any level of geometric entity. The one thing that can't merge is the actual two volumes themselves. So if you have two identical cubes that overset with each other, you can't merge the cubes together. You'll still have two volumes. But otherwise, all of their children entities can be merged.
If there's nothing else, then thank you again for attending. Thank you, Greg, for another great demonstration. We'll see you all next time.